Hey, so I just wanted to give a quick tour of my new mechmidi device. It's essentially like an instrument and a MIDI controller and a sequencer and I don't know anything else you can really think of. Um, each one of these mechanical keys has an RGB LED underneath it, and they're really easy to program. And I have like example code for everything. There's two rotary encoders. Each one has like its own button, and then infinitely can turn. And it's got an OLED display. Um, I even wrote like some menu code to make it like really easy to make like little menus for it and stuff. So it should be pretty simple to use. Um, it's pretty basic, but it's got all the stuff that I was needing, so that's why it exists. I think some problems are maybe just in the design. I had these buttons, like these keys, perfectly spaced in KiCad, but when I put it in Easy EDA, I think it's called, which is like the program that the board manufacturer that I was using, it's like what they made, because it was like easier to get the parts set up and everything. Um, anyway, when I transferred it over, the spacing somehow is off. I don't really know why, but they're just a little too close to put like standard keycaps on, which is pretty annoying because originally it worked fine. I actually have the original board that I got printed in another place without any parts, and it's all spaced like perfectly on this. So that's a little frustrating, but it's kind of expensive to like do a whole nother hardware run. So I'm probably not going to, honestly. I feel like there's some workarounds, like you could shave some keys down maybe to get them to fit, or I don't know, maybe something like that. Maybe I can find some smaller keys. I've been looking around, but if I can find a keycap, I'll make a note of it in the GitHub. But yeah, so that's one problem. Another problem is the board, the Raspberry Pi 2040, like the Pico. This is like a Pico Zero, and it's perfect for this project because it's so small and it's meant to be soldered onto the surface of things. But they don't mention that there's like a chip underneath it. So when you put the two together, it actually sits up just a little bit. And so in order to solder it, you have to kind of bridge solder across the joint to the board, which is really annoying. I think maybe a fix for that would be to like cut a hole in the actual board here, in the design process, like cut a hole in it so that it fits flush, and then it'd be much easier to solder. Again, you can work around it, so I probably won't like do a whole nother run just for that, but those are two things that definitely frustrate me. But anyway, so here's the device. So I have this SAM MIDI chip that it can actually do a lot more than what I'm doing here in terms of demos. It has all these options for effects and all kinds of other things, but I've got a basic player here, and you can change it to any of the patches that it has built in. It has 127, and there's actually another mode. You can go to the extended patches and you get another 127, and I didn't include that, but they're pretty much the same stuff. They're just like slight variations, so it doesn't make a big difference. And then I also added this one's like specific to drums, and the only difference really is that it knows the names of the variations. But again, the variations, they're not really that different. Like, so power, for example, is slightly different. Like the snare is different, but that's it. Everything else is the same. So I don't know how much utility you'll get out of that, but that's the idea there. So if you want to quickly, like, play a beat, it responds pretty fast, and you can at least like see that your chip is working. That's something. Um, and I have some other various demos, just like input and LED demos, little things that just kind of show off things. The main idea with that was that I wanted code for every single function that I'm going to use, so that so it's easy to just like copy and paste like what I need to make custom devices or whatever. So there is demo code for basically everything on the board, and it's pretty simple. Like, you just set the color for buttons, or you read the keys, and they just give like a numeric key. So like, this is 0 and this is 19, because there's 20 keys. That kind of thing. They're very simple. But yeah, that's it. There's a couple other things, like these two MIDI demos that if you connect it to a computer and you send it MIDI signals, you can see like what the computer's outputting. And I just did that as like a basic utility. And also, I think eventually this is going to be like a USB MIDI device as well as a hardware MIDI device. So I wanted to make sure that all that worked and everything. I think that's it.